Hi, hope everything is all right. Today I want to do something a little bit different. I've made this new shelf called Layout Tools, and I'm gonna basically build some layout tools to help you with modeling and just sort of show off my thought process when building some scripts and when thinking about multiple scripts that fit together into some kind of tool set. And yeah, I hope that kind of shows off a little bit more about the Maya commands that are there and how you can tackle this kind of thing. Before, in the future, hopefully, I'll be making some more UI driven tutorials where you make custom windows and stuff. So for now, we're just going to use a shelf and straight up Python in Maya. But yeah, that said, let's show a little bit what I mean by layout tools. So if you work with games, this might be a little bit more familiar to you. But basically, the idea is that if you have a bunch of assets, like here I'm making a little pillar and a little disc for the floor and a little roof, so we could maybe make a little tower kind of thing. Then these would be your main assets, and then in your scene you would put this together and kind of try and make make some models and mock up your scene, or not mock up, but really fill your scene with props. And instead of modeling every pillar by hand, of course, we're going to reuse the same pillar. But the main thing that you probably want to do is you want to work on a scene, and then you want to update this model because it's a cube and your mockup is working out. So now you need to update the cube with a newer high-res model. And that's where you could go in and duplicate your new cube. So let's say we have beveled this cube, and now we want to update all the models to the bevel version. So you could duplicate it, parent it, zero out the transforms, unparent it, and then delete the old one, and then do that for every pillar. That's a lot of work. And also, if you freeze transforms, then that doesn't work anymore, because if you parent it and try to zero out the transforms, it might not do what you expect. So that's not going to work. Another option might be instancing. So let's delete all this. In Maya, when you say edit duplicate special, what you can do is you can set this, instead of copy, you can instance, and you can duplicate special. And now these two models are actually the same. So I can edit the vertex of this one, and you can see they both update. But the problem we have here is, let's say I want to add like a little chimney to this roof. I'm going to add this cube, and I'm going to hit combine. And now my other roof disappeared. But that's also not really an option. And the final thing that Maya has that is kind of like this is referencing. So you could export every individual asset as its own Maya file, and then try to reference these files multiple times into your scene. So you would reference every single pillar. That, however, it doesn't scale that well. So if you have 1,000 pillars in your scene, Maya really grinds to a halt. It doesn't like you doing that. So it's also not ideal, and there's tons of other stuff that might go wrong when doing that. So I really don't like that as a workflow, as a solution to this kind of problem. So then we're thinking, how can we make this better? How can we make this more flexible? And I personally think that if we have the ability to just duplicate stuff as we normally would, like the normal workflow that you like, just to move things around, change the pivot, snap them together, maybe even freeze their transforms, like all these things should be possible. And then there should be a button that just updates all of these pillars to whatever we change this pillar to. So my current idea is to, when thinking about this, to kind of figure out a way to track information of where did this come from? How was this pillar originated? One way we could do that is by adding an extra attribute that kind of identifies this object. So let's say we add an attribute and we call it identifier, and that's going to be a string. We add it and we can just say, this is the pillar. Now when we duplicate this pillar, that attribute is actually remembered, and it's kind of difficult to change even. So if you start working in a scene like this, all of these guys will have that pillar attribute. So we can find the original pillar because they will have the same identifier. Then the only problem might be that you want to know which is the real original. So we could just do this in a group and call it originals or something. And then we can look for an object with this identifier inside the group originals. And then we know which is which is an instance and which is the original. So that's one problem solved, where we kind of create a link between the objects. It's a very soft link. I mean, if I change the name here, things will break. And we still have kind of the problem that if you combine two models, then that attribute will disappear. So when doing that, you have to be sort of mindful to keep your identifier on the original object up to date. But we could probably ease out those processes with some scripts to help you out there. Hopefully that will not be too hard. One other thing though is if you freeze transforms and if you change pivots, things are not easy to replace anymore after that. Like, I don't really know how this mesh should be moved in the world. Like, so let's say this is an updated pillar and I want to put it in the same place. That's kind of difficult now because I don't have the transform anymore. So another thing that I like to do is to create some locators and parent them to the original object. And I'm going to create 3 locators, and they're all going to be... Wait, let's freeze transform first. That's just for my own sanity. This should work without freezing transforms, but it just looks nicer if I freeze transform first. I've got 3 locators, and they're going to be the X, Y, and Z axes. So I'm going to translate X, translate Y, and translate Z, all by 1. And then we'll just hide the locators. But the idea is, I don't hide them just yet. You can see what happens. If I take this model and duplicate it, I can scale it. And you can see the locator moves. I can rotate it, and you can see they kind of keep their relative local orientation, just like the move tool. And now I can freeze transform. And the move tool reset, the rotations of the locators reset, but their relative positions did not reset. So we kind of see that these locators are our original X, Y, and Z direction. And we even know from the name which is which. I think I'm actually going to add a 0 as well. So I can actually measure the difference between the origin and the locator, just in case you change the pivot, right? There's no reference point anymore after you change the pivot. So we want that extra 0 locator. How to utilize this is going to be some scripting, and I will show you how to do it. But this is the information that we actually want to retain. It's the transformation of the object, and it's going to stay. That information is going to stay there after freeze transforms. So we have the original transformation from before you froze transforms. You could also just say never freeze transforms. By the way, that's totally valid. But in my experience in a production scenario, people always do that because it's a cleanliness thing. You delete your history, you freeze your transforms. It's part of the workflow of a lot of people that work in Maya. So to just say, oh, you froze transforms, now you lose all your work, that's a little bit harsh. I like tools to be a little bit more user-friendly than that. So yeah, that's kind of the solution I have in my head. And now I'm just going to try and build the tools to make that happen. So first of all, I'm going to switch to this program called Pycharm, which I don't think I've talked to you about this yet. It's a third-party tool. There's a community edition that's free to use, and you can just write Python in it. So I opened my Maya scripts folder, which is currently empty because this is a fresh installation pretty much. I'm going to create a new package called layout tools. So that's going to be something I can import. So I can say import layout tools. Then let's print the result. Didn't print anything, did it? Right, yeah, so it finds the layout tools right here. So that's, I'm going to be using that editor instead of this one. So here I can just say import layout tools, or probably from layout tools, import whatever. And then I can reload it and I can call functions inside of it, such as initialize, original, or something. Probably the first thing I'm going to write, like how do you automatically place these locators and add that identifier attribute. I'm going to make a little script for that. And then this is just how I will try and interact with my external script file over here. And then this can go on the shelf, and then the shelf is very minimal. It's only containing imports and functions or executions. And then all the code will live in the Maya documents Maya script folder. And I'm using this external editor because it's just a little bit nicer to use. It has some nice autocomplete features and syntax highlighting, and just I work a lot faster in this tool. So if you have a text editor that you like, you've already been coding in some other language, I would always try to use that instead of the Maya one, because the Maya one is just not very great. Another thing is I can actually set it to use Maya as its interpreter. So Maya has their own Python executable, and that's also how you do standalone Maya. But for now, I can import CMDS and actually get, oh, or not. I guess autocomplete isn't working today. No, well, that's too bad. You can usually set up autocomplete in external editors as well, but I haven't done that yet on this PC, it seems. Right, so what are we gonna do? We're gonna ask the user to select an object. So let's say these two are not set up correctly yet. This one is. I'm gonna call this pillar. I'll call you floor. Call you roof. And what I want is I wanna take this selected object and put it in the originals folder. And I wanna add that identifier attribute, and I wanna add these locators. So first things first, let's get the selection. We should probably check that the selection is length 1. We should probably check that we only have a transform selected and not something else like a material or something. If we don't have a selection, or the length of the selection is not equal to 1, we can just give an error and say, please select exactly one object. This might be a little bit small, actually. Let's see if I can zoom this text for you. This is the editor. This one, yeah, it is. Cool. I forgot what it was. 13. Maybe 18. Better. That looks a lot more readable. All right, so let's create a function called initialize original. That will get that selection and throw that error. If there is no error, we can immediately start creating some locators. That's a function called space locator. Don't recall exactly how to name it, so let's grab the documentation for that. Yeah, you can just provide the name like that. So I'm gonna have name 0 x y z, and I think you can already see, like, I can duplicate lines in this editor, which is why I prefer to use it, because it saves so much typing and copy pasting and stuff. Pretty nice. Then I guess I kind of want to know which is which. Well, let's just make a list out of them. Locators equals, these are my locators. And then I can set locators 0. No, that's 0. 1 is going to be the X. I'll translate to be 100. And let's change it to Y is 1 and Z is 1 for the other two locators. So this is going to be the translate attribute, and I want that to be set after I parent the object, just in case the pillar is over here. Let's say you create a new locator and you set X to 1, and then you parent it to the pillar, then it's actually not going to be correct. So we have to parent it first, and then we have to set this to 100. Then it's good. So We can say CMS.parent and then the locator 0. Well, all the locators can be parented to the selection 0. I think that's how it works. Maybe this needs to become one list or something. I'm not 100% sure. No, actually, that's going to change the name because, yeah, X already exists, so we'll probably get a full path name to the object. So let's change this. Basically, the list of locators will become invalid after this command because these names are out of date. So I'm just going to make a create and parent step here. Every locator gets parented immediately, and then I store the name. Just copy paste parent selection. All right, so this should achieve the same thing, but in a slightly different order. Thinking this might return a list as well. So let's actually run this code real quick. Interesting. Oh yeah, I changed the case here to capital O. I've got 2 objects selected, so that's why it's mad. And now we run it. Okay, yeah, here cannot concatenate list. Can only concatenate list, not string to list. What that means is that we are trying to add a string to a list. So you just get, well, I just do it here. Just get element 0 after the parent. So we get the first item in the list, and we know we're parenting 1 object, and exactly 1 object will be given back to us. So that list is always length 1. All right, that seems to have created some locators right there. I'll actually run it twice. So that's also this kind of annoying. You don't want to disrupt the workflow. So when you click a button, you basically don't want to change the user selection. So what I tend to do is get the original selection. And then at the end of the command, I just say, let's reselect that original selection. And then there's some other stuff there. By changing all this stuff, it might be more than one undo. So I also tend to do cmds.undo info. And you have open chunk equals true. And let me double check that because I usually use the short name. And I find this is a little bit more readable. Yeah, so you have open chunk and you have close chunk. So before making any changes, we say this is going to be one undo. Then we do a bunch of changes, and then we say, okay, this is the end of one undo. And then you group all these actions together as one undo. One other issue, though, is if there's an error in this code, like this error happens, now we've opened a chunk, and then the error happens, and then we stop the code. So now the chunk is never closed, and that's really bad. So we also want to add a try and a finally like this. And now all this code will happen as normally. And if there's an error, the error will be output to the user as normal, but the finally lets us inject some additional code just after the error happens. So that's just going to clean up. We're going to restore the user selection. We're going to close that undo chunk. And you could even do a different version where if an error happens, that's in accept, then you just close the chunk and you undo. So nothing has changed. We're back. There's no additional thing in the undo stack. Like if you press Ctrl Z here, nothing would happen. If an error occurs, we didn't change anything. So there's an empty undo chunk there. And this way we create an empty undo chunk and undo it immediately. So the scene is really as it was before the code ran. That's a little bit nicer even. And then the exception actually, Python's accept will actually just take over exception handling. So this code is now running and no error will be printed to the user anymore. So to go back to, oh, there's really still an error and you should show that to the user, you can also type a raise at the end and then the exception just continues as normal. But we just injected this little bit of code if something goes wrong, and we inject this little bit of code if something goes right. I mean, that should be else actually. So it's accept and else. This is if an error happens. This is if no error happens. And finally is anyways, both cases. Error or no error, that code runs. But we kind of want to separate the two. Because if I do accept and finally, then the error happens. We close the chunk, we undo. And then we get to finally, and we select, and then we close the chunk. And that's closing a chunk twice and opening it once, so it's going to be an issue. So yeah, this should definitely be an else. So 2 more steps to do. Let's actually 3 more steps, because first I'm going to document some stuff. Given one selected transform converts it to original object in the layout tools. Add locators to maintain space after freeze transform. Hidden. So we're going to hide those locators. That's one step we need to do. Parent it to a group named originals. Add an attribute identifier attribute containing the node or the transform's name. The renaming may be wrong, but we can still track which object is which. Let's see. We might also want to log attributes and node, so it cannot be changed by user. Yeah, setting the identifier is going to be a little bit complicated, because I don't want 2 names happening at the same time, because that gets confusing. So if I go back into Maya, let's say I have this pillar and now I rename it to column. Then we look in the attribute editor. There is still pillar as identifier, which can happen. And then I create a new object and I call that pillar. Now, if I were to run the script and use the name as the identifier, we have the same identifier twice, and that's bad. So we want to just check for that and then just tell the user to rename their object to something else. First, let's hide these locators, 0, x, y, z. Then parent the selection to originals. If not obj exists originals, create an empty group named originals. I forget how to do this. Can I do it like this? Maya import cmds. No. I have to give it a name. Make it empty. Yeah, okay. Sorry, I just had to check how to name the group. This is how you do that. Ensure originals group exists. Already made a typo. Lock group. We could actually lock and hide it all together, maybe. I don't know yet. First, we lock the node, and then just have to lock the attributes. I think this is how you do that. Let's give that a go. So what this does is it means that if you have this group, you go to the channel box, you right click, lock selected. Now you can't move it anymore, and that's kind of what I want. I don't want people to accidentally touch these objects thinking they're not the originals. You can just click on it on the viewport and move it, and then that's going to be confusing. And you don't want to accidentally delete this group either, because it contains all these important objects. So that's what you can do with lock node, which I don't think you can do in the interface. So there's just this command called cmds.lockNode, and you can set lock is true or lock is false if you want to unlock the node. And that means you can no longer delete the object. And I think you can no longer make connections to the attributes of the object, and that's kind of nice. We're actually going to make a little helper function called log transform. That was not a copy. I should probably see what happens if I set enter originals.translate log equals true. Does it do the 3 attributes? Yeah, cool. So this will work, and it will just do 3 attributes at a time, which is a lot nicer than having 9 log attribute calls, right? So yeah, this logs a transform. You just throw our originals at that, so it's kind of safe from user manipulation. And I'll do the same with the original. So this selection gets reparented. I'm going to lock that one too. I think we have to get 0 there. Just return a list. Cool. Okay. Make locators representing the local space. Parent the object. I guess before we lock it, and maybe before we parent it as well, we should add that attribute. So well, we can say parent the original, lock the original. Then we can say add identifier in between, because I think if it's locked, you're also not allowed to add attributes. Should probably keep this lowercase, because that's what Maya does as well. And let's pull up the documentation again, because I don't know how to make a string attribute. dt equals string. Okay. So that should create our identifier, and then we can set it. 0.id can be short name. I'm going to make a function out of that. Type equals string. And just in case you have a long path name, which we tend to do, I want to make sure we can clean that up. So you can split by the pipe character. So a path like this can be split into multiple pieces, and we can split from the right only the first one. So we'll start looking from the right, and then we'll split right here, and then we get these 2 strings back. And then we're only interested in the last one. It's that simple to get the short name. We might already have a short name here. I just want to be better safe than sorry. Okay, yeah, I think we've executed this entire plan. Let's give that a run. We put this on my shelf. Invalid flag D. Oh yeah, that has to be DT. Little typo there. All right, so this is where not having autocomplete really bites me. Like in my eye, it makes valid words blue, and if you make a typo, it's not blue. And here it just says I cannot find any of this because I didn't set up Maya correctly. Which, I might do later, but not right now because I don't remember how to do it. All right, so that created a floor original, which we can't move, we can't delete, just there. I guess I wanna redo this one. Maybe I want to support having the identifier already. So this is gonna be an error. No, it made it twice. Oh, this one has a capital letter in it. Okay, let's just delete it then. Okay, so that's my original setup. And so one idea here is, yeah, you want to duplicate this and move it, but that's now it's locked, so that won't work. So I also want to make a button to create an instance. Once you have one instance, this is fine, by the way. It's you can keep duplicating the instance and it will always point to the same original. But just when you're starting out, you need a little button to free these lock nodes. Yeah, I guess we want to get the selection again. And this time we want to make sure that it's inside the originals group. I'm just gonna try this in Maya. I'm sorry that's a little bit small. Wait, I can just do it here, right? I'm gonna try and see if we can do something like this. Yes, we can. So now if I select the transform outside of the originals group, we get nothing. And if it's inside, we get the transform. Sorry, that's why I moved here. And I forgot to zoom in. Anyways, that's the plan. So let's do that. And then we have the same check. If there is no selection or the length is not equal to 1, we can just give us the same error. And then we can actually start unlocking that node. Let's actually do this a little bit better. Have the default lock equals true, and then the unlock is just going to call lock. It's a little bit nicer, I think. We're going to duplicate the selection. We're going to unlock that copy, which is going to be a list. And then we're going to parent copy to the world. So it's no longer parented to the originals group. And I guess the same applies here with the whole try except original selection thing. I guess this is just a paradigm that I'm gonna copy everywhere. There are ways in Python to hide that. So you can use something called a decorator, where you change a function to wrap some additional code around the actual function. But it's a little bit difficult to set up, and I don't want to clutter the conversation with some irrelevant Python knowledge. Because, you know, this works. We can do what we want to do. Okay, so let's go back and say layout tools, reload layout tools, and then tools.instantiate original. Edit this one, say make copy. These, you know, for polish, you want to find icons and good descriptions and tooltips. But right now, while working, I'm just going to give them a quick note for myself so I can kind of recognize which is which. I'm just going to take this floor and copy it. Right, that works. Actually, I don't want to restore the selection if it goes well. Yeah, I just do it like this. Yeah, because then we can just continue with the floor we just copied. Move on with our life. Another thing I just realized is that we can, when making a building block, we can just call this function and then hide the original. I'm gonna do that. Copy the original or instantiate the original so we have a workable copy. Hide the original. Or maybe not hide the original, but we'll just hide the entire group called originals. There we go. Yeah, I'm just gonna clean this up real quick, or maybe let's just do a new scene because I want to test my new features from scratch. So I'm just gonna quickly make the same setup. Freeze that. And this is for pillar roof. And then we can turn all of these. Oop. Ah. Not sure if it's still going to be selected. Yeah, it would be. So the instantiate actually doesn't take an argument. It just instantiates the selection. But I'm pretty sure that our selection is still correct at that point in the code. Yeah, so now we have, okay. And then I want to also not select the original here. Okay. Yeah, so now I have a working copy that's pointing to the original roof, which is just completely invisible, and it has the locator setup, and this one also has the locator setup. That is exactly where I want to be. There's just one button to convert your model to a building block that you can then duplicate around the scene. Ooh, the pillar pivot is off. Fix that first. And like right now, changing these is a little bit complicated. Like the pivot was off, I had to undo everything and redo it from scratch. Of course, the goal is to eventually make that way more user friendly. Yeah, that's it's kind of the gist of it. And now we have to talk about updating the original. So what if I have I want to work on this pillar, for example? Then what I would probably do is I get the copy, just put it here, or I select the pillar and make a new copy. I'm just gonna polish this asset, right? I'm gonna make it look better, look nicer. Of course, we don't have time for that, so I'm just gonna add a bevel. And now this model is what I want to have as the pillar, as the new pillar. So I think it's fair to say it has to be with the same pivot and the same position as the original. So if you make a new copy, that's exactly what you get. So it's easy to reference. Is this in the same space? Then you have to freeze the transforms. Maybe we can do that in the script, maybe not. Not sure yet. Let's delete history as well. Now this is our pillar, and we're gonna update that original. So, well, this one we started from a copy, but that we of course cannot guarantee that this identifier is on the new pillar. So I think it's fair to say you have the new pillar, you have either the original selected or another pillar in the scene, and then you have a button called update, and it just finds the original and changes the model, and then it finds all the copies in the scene and updates all of them by replacing them with the new model. That is what I'm gonna do, I think. So I've got the new and the old. Like that. And then we're gonna make a function that just looks like this. Or maybe just update all. Update selected, I'm not sure. Update instances. Like I'm replacing the original and then I'm gonna replace all the instances. So I'm just gonna make this long function name that describes what it does. So first of all, I'm gonna expect two selected transforms. And then the second object, which is the old one, should have the attribute, the identifier attribute. We can actually do obj exists selection dot identifier. So checking if an object exists, you can use the name of the object, but you can also check for attributes by just adding the attribute. So if that is not the case, then I guess we can just say same error. I'll try and give some helpful info. Like maybe you selected old and then new instead of new and then old. So I think that's always good to be a little bit more descriptive about what might have gone wrong. Let's see. Okay, given that information, we have new old equals selection, and then getter old dot identifier. Yeah, that's actually not entirely true. The selection might be an instance, so I'm going to get the identifier from the instance, and then I'm going to find original with that identifier. I'm going to create a function called find original. And here we're going to use the same trick. We're going to list all the objects inside the originals, but instead of the selection, we're just going to get the transform. And I guess we can filter that further. Let me check real quick. This works. So if I say list with identifier, then I get everything with the identifier. Maybe this will even work. Yes, so I've got all the originals that actually have the identifier attribute. And that's, to me, that's important because I don't, like, what if you accidentally throw this in there? Like, I don't want stuff to break in that case. So we're just going to look for originals that are properly set up and have the identifier attribute. We get the attribute. So as you could see, or well, it's also a little bit small. In the results here, when you do this, it actually gives you the not just the object name, but also the attribute name. So when I'm going to get attr, I don't have to do plus dot identifier. I already have that full name. We're looking for an identifier. So if these are equal, then we can return that original. I'm actually going to say what happens if I the full path name of this. Okay, that's good. Do that. I'm going to strip that attribute name off of there. So I'm going to get rsplit dot one, or actually split dot one, I guess. So we just split on the first dot and then we get whatever is in front of it, which is the original that we're looking for. And if not, it just returns none. So that's going to be the old object. We're back in our main function where we trying to find the two objects that we're going to substitute. If old is none, we have to throw an error, an expected error, not find original object with identifier %s, and then this is the identifier. Okay. Then we want to replace the object, the old object entirely, so we can get the position of the old object. Get the world space matrix. And then we should probably steal its locators, maybe. I'm not sure yet. First, I'm going to make sure the new object is in the same exact position. Yeah, I guess we could steal the locator. So if we have the identifier, no, sorry, we have the old object, which is, it should be in originals / something. We could also say there's going to be a 0 locator and an X and a Y and a Z. So these locators are going to exist. And I'm gonna, oh, sorry, that was unlock transform. I'm gonna free up that locator so I can actually reparent it somewhere else. Actually, we didn't lock the locators, did we? No, we didn't. So, okay. I think that's fine. I'm not gonna unlock it. I'm just gonna leave it as it is. We're just going to parent that locator to the new object. So we're just stealing away the local transform as it was. Then we can actually delete the old object. I'm gonna rename the new object to match the old name. Maybe it's not super necessary, but I think it's nice. And then we're going to parent the new to the originals group. And I don't need to check whether it exists or not because we can never get here if we don't have an original. So that should be fine, basically. This error would trigger before then. Okay, so that's the new object, and then I guess we can log transform the new one. All right, that's update original. Validate the selection. Get the original objects or all objects. Copy the position to new. Move locators to new. Delete old. Rename new. Parent it to same parent. And lock it. This is old. Okay, that's the date original date instances. Okay, so we have an original right here called new, and we basically want to find all the objects that have the same identifier. So we can again do this trick where we just look for the objects with the identifier in the name. Just want to look for type equals transform, and we want long names as well. It's fairly important. Because by having log names, we can actually check. If it starts with originals, then it's parented to the originals group, and this is not the instance, so we want to skip that. Do not replace originals, only instances. All objects with an identifier. Do not replace objects with the wrong identifier. Oh, that's what I forgot actually. After stealing the locators, we also have to add the identifier to the new object or to the new original. So let's see, we can steal that add attr line and that set attr line. Move that to a function. Identifier. Cool. Moving this code around so we don't end up with the same code twice. Which I think I already failed at doing that everywhere, but it's a good practice. Right, so we're doing that here. That's going to be new. It's going to be the identifier that we previously got from the old one. Yeah, get attr instance. This also has that dot identifier in there, so we can just immediately get it. Not super comfortable with this name being so generic. Might rename the variable later. First, let's try and finish this up. So we can instantiate the original. And now I am going to change it where it accepts an original to instantiate. If original is none, then we get the selection. I guess we can also return the copy, which is nice. Right, so this, if I'm not giving an original to instantiate, it's going to use the selection, so it's going to behave the exact same way it always has. But now I can actually use it here. Say, let's instantiate this specific object. And now we want to kind of do the same trick as here, where we steal the position and move it there, and we delete the old one and then steal its name and its parent and everything. But we cannot guarantee that this matrix is valid because you might have freeze transformed the instance. So this is where the locators come in handy. So we get the instance matrix from the instance, split by attribute. Sorry, I'm going to get the short name of the instance first. So remove that attribute, that dot identifier at the end. We just have the node, and then we get the instance matrix from locators, or just the matrix from locators, I guess. You just say that matrix from locators, node plus 0, x, y, z. We can use Xform to get their world space translation. And this is row 3, row 2, row 0, and row 1. Except these have to be made relative to this one, I believe. Row 0, 0, 2, 1. And then that ugliness has to happen all the rows. I'll elaborate in a little bit after I got this working. Okay. Yeah, let's take this code into Maya. I'm gonna try to demonstrate a little bit what's going on here. If I show you these locators right here, let's move that to a shell button. And then this node equals pillar 4, pillar 4. So this is my node, and these are my values, and these are going to be the world space positions of these locators. And yeah, this weird number, that e minus 16, means it's very, very small. That's correct because this is practically at 0, but almost, not entirely. So this, you can interpret this as 0.0. And so this is that X locator that's, you know, it's a little bit off in X, and it's on 0 in Y and Z. And this one is the Y. So it's a little bit off in all the X's and exactly 1 up, which is correct. Like we moved this up 1 and the thing is on the floor. Then row 2, same 3. That's the actual position of the object, so that should actually match the translate that we see. No, that's incorrect because we rotated the parent. So if I unparent this one, world space, then we have minus 2.29 and 0.707. And then the row 3 has exactly those values. So that is the position of the object. That's good. That's what we want to know. But then the rotation in a matrix is defined by not like 3 values, like angles, but it's defined by these 3 arrows that you always see when you're in object space. So if you change your tool into object space, you can see the arrows pointing, and that the positions of the points of these arrows are basically your orientation matrix. So what we create is actually a list of this point, this point, this point, and this point. And then together they kind of describe the center of the widget, and then the red arrow, the green arrow, and the blue arrow. And the arrows have to be relative to the center. So that's why when we get this position, we actually want to subtract, so that I can show you this. If we have a pillar just somewhere in the world, but it's not rotated, the value of this one is still 100. That's what we care about. So if I get the Xform world space matrix, this is the values that we want to build, right? So when you get a matrix, you can see there is the x-axis is 1 in x, the y-axis is 1 in y, the z-axis is 1 in z. So you have these 3 rows describing these 3 arrows, and then you have the actual position. And when you start rotating, then these become different, because now the x-axis is in world space relative to this point, it's slightly off to the right and slightly off in z as well. So you have if you get that matrix again, delete the command, of course. There. Now you can see this is almost 1, and this is slightly less than 0. And that's the information we're trying to get. So if I get these locators in world space as their positions, does not like me. Oh, I unparented it. Sorry. Let's go back to where we were. Now row 0 was like that position, but if we subtract this extra information, now row 0 is relative, and it's going to be off to the right and in negative z as well. So you can see this is the point relative to that point, and that's exactly what the matrix would give us. So if we do again Xform node query world space matrix, then the first values will be those values. So we just made up those values from the locators instead of getting the matrix, which is cool because now I can do freeze transform. I select this pillar. Now our matrix is 1000, but our logic, our version of getting the matrix, actually gives us. Oh, did I do something wrong? I think I did something wrong. Oh no, it's this stuff. It's really bad. How do I fix that? So apparently if you freeze transform a locator, it changes the local position as well. So I don't want the position with Xform. I guess I want the rotate pivot. Yes. Cool. So now our row 0 is still what it should be for a pillar that's rotated 45 degrees. Like we want this line, not this line. And then we have to fill in some extra numbers because there's always 4 numbers on a row. So it's like 3 zeros and a 1 at the end as columns. Let's get this out of there. So this is the position. This is describing the rotation as 3 independent arrows. And that information is lost to the Maya transform, but we have managed to store it in these locators, which if they're invisible, you don't even care about. It's just there. So now, I realize I might have had some of this off screen. Sorry. I hope it was all visible. But the main thing I found out is that when you freeze, the translate actually returns the wrong value, and the pivot is still in the right place. So I'm changing this to rotate pivot. We get these 3 or these 4 points. Then the last point gets a 1, and that's the position and the 1. And then the other 3 points are relative to the last point, and they get a 0, and it's just the 3 arrows describing the rotation. And that is the matrix that you would normally get if you do Xform query matrix, but including freezing transforms. So we've got that. This was a nice little detour. And now we're going to apply that matrix to our copy. Our copy is not freeze transformed, so that's copy world space matrix is matrix. This should just put the object in a new place. A copy to the right place. Delete the original instance, or delete the old instance, I guess. Its parent and name. And actually, I just realized that this is in the wrong order. So instance r split pipe 1 0. What this does is if you have a name like this, it splits on the last pipe, and then it takes the preceding string. And that AB is the parent of C. So that's what we want. This is the parent. And then we're going to parent our copy to that new parent. And then we are going to rename our copy to the old name, actually. So we don't even need 0. We just need both of these components. I think that's it. I think that should replace it. Did I forget anything? Maybe, maybe not. Let's test it out. So I have new and then old. Say these. Error. Selection plus identifier. All right, I see. Got the 1 over there. Found no valid items to add the attribute to. That's weird. 145. Print new. So strange. Do you already have the identifier? Yes, so I guess the error is the attribute already exists. If cmds.obj exists, node plus dot identifier. Is there a delete attr function? Yes, there is. So I think I'm just gonna do that. The reason I'm deleting it and not just using it is because what if it's not a string? So I think this is a little bit more safe. Not delete locked node pillar. Oh, that's correct. So when we're replacing the original, we need to unlock it first. Ah, okay. So when unlocking a node, we need to first unlock the node and then unlock the attribute. So this trick is not going to work. We're just going to move this over here. And these are going to be true. These are going to be false. Go away. There we go. New name contains invalid. I guess we're renaming something to the full path somehow. That is kind of weird though. Original pillar. Ah, it's this one. It's this one. So short name. Happy we made a function out of that. Okay. Don't see all of these other ones update though. Yeah. What's up with that? This is not giving us anything. Ah, this is why we're not allowed to filter by node type and by attribute name, it seems. But then I guess, yeah, we never did that before. I thought we did. Okay, that's fair. That's fair enough to me. Parent, copy parent. Interesting. Ah, right. So if there is no parent, then we don't want a parent. And there can be no parent because, you know, this is not in a group or anything. It has no parent. That's totally fine. Cool, that did the job. Look at that. The beveled pillars now. And I guess we could like start modeling into this and say I have not modeled in Maya since before they changed all the interface and moved all the buttons around. So I can never find anything. Let's give this some edge loops. Let's give it like differently sized endpoints. And then let's get the old. Now this is the new actually, or you know whatever. Polysurface 5. Get the old pillar in the originals and then click update. That is awesome. Really cool. That makes me happy. The only thing I guess it shouldn't have done is delete this instance, because what if that's something I'm actually working on? Like what if I change the roof and then update the roof, then it would delete the roof. So that's bad. When I'm updating the original, the new one, we should just duplicate that one. And that way we have a fresh new object that we're gonna put into the originals folder. Whatever we're working on might have already been an instance that we have modified, and it's going to be replaced by replacing the instance later on. So just to clarify, let's add some edge loops in here as well. Oh, that doesn't even work. You have some kind of cool slicing tool. So if I update this one, what's going to happen is we're going to get a copy. It's going to replace this one. That's updating the original, and then updating the instances is going to take that original and put it back here over our roof. So like that. You can see it jumped because it actually made a new copy and replaced the roof that we had. Right, that's kind of what I wanted to illustrate today. I'm sure there's more work to be done on this, but off the top of my head, I don't find anything yet. I guess I have to just try this out for a bit and see if I can come up with new ideas to add to it. And maybe I'll make a follow-up video. Maybe I'll do something else next time. But yeah, I hope this seeing this thought process might be helpful, and seeing a little bit more of Maya might be just interesting to you in general. And with that, I guess thanks for watching.